planar surface and planar surface. Interaction. Right? If we have two infinite plane surfaces, then the interaction will become or can lead to an infinite interaction, or it can get out of our calculation capabilities. So to circumvent the difficulty of dealing with two infinite surfaces, we take a surface and a unit plane surface. So the interaction of a plane surface, two plane surfaces per unit area, right? And not taking the infinite surfaces, not taking infinite surfaces. So the infinite surfaces could be like this. Right? But that this will lead to infinity, which will be difficult. And suppose that is the separation, right? So we don't do this. We don't do this, right? We will do something like infinite line surfaces and a unit area, right? Some unit area, right? Area distance G from each other, an infinite plane surface and nearby it a unit area. 1 meter cube or 1 centimeter cube or 1 nanometer cube, something like that, of unit area, right? So this surface will be a unit area. Right? Okay. And we said length of separation between them is d, right? Let these two surfaces have concentration, density, number of molecules per unit area is equal to rho, right? D and by dz, right? Where z go in this direction. And for example, this little small ring type will be like, right? That will be dz. This little place here, that is what? Dz. And z is like extending into the right. Right? So here, Gn, the total number of molecule in this ring, we consider a small ring kind of piece around the unit area, right, of thickness dz. So here, the number of molecules will be this, right? That is the molecules between in this little ring kind of pattern or kind of shape, right? Okay. So if little small omega or small w, we say, right? This is small w. X separation G, right? That is the interactionality between this surface and this little ring. Right? So, and the area, we say this area is equal to
1.
we said that's 0, right? So now we integrate this over the whole wall. This little ring over the whole wall, right? So we can say that the interaction energy between this unit area and this plane surface, that will be equal to integrating the smaller energy, right? Where all the molecules present, right? Okay, that could be like we know the interaction energy between a ring type of surface, by putting the value of omega of d and putting the value of the n, right? And here I took out n minus 2, n minus 3 and these things because they are constant, and I left 1 over z to the power n minus 3. That is for the small w, which is the interaction energy between this small portion and a surface, like a small ring kind of portion. Okay, now for dn we write it, sorry, dz, rho dz, right? And now it goes, the z goes from d to infinity, right? From d to infinity. Okay, so that can be written as minus 2 pi rho square into c over n minus 2 n minus 3, right? And I integrate this. When I integrate this, increase the power by 1. So it will be 4,
N minus 1.
right? So it will be like z 4 minus n or 4 minus n from d to infinity, right? And that is minus 2 pi rho square c over n minus 2 n minus 3, right? And that will be 1 over 4 minus n, and that will be 1 over infinity minus 1 over d to the power n minus, or after putting these limits. This will be equal to minus 2 pi, right, rho square c for n minus 2, n minus 3, n minus 4, right? And 1 over d to the power n minus 4. 1 over d to the power n minus 4. Right? Let this is. So that is the interaction energy, right? between, this is the interaction energy per unit area. Look, we have taken A is equal to 1. So it means per unit area. The interaction energy
Per unit.
per unit area of two plane surfaces, right? That is equation number 2. And that is interaction energy between plane surfaces per unit area. Good. Okay. If we say, if we talk about the van der Waals interaction, for van der Waals n is equal to 6, right? So for n is equal to, for van der Waals solution, n is equal to, when the energies are van der Waals energy, right? Then the interaction energy, H separation D equal to minus 2 pi rho square C by 4, 3, 2 and D square comes out to be minus pi C rho square 12 and D square. This is like one unit area and another infinite area, and the separation is like what? The separation between the two. And if I look at this from the side, it will be like this. And this will be what? Say it enough. If I take a picture from the side, you can be like that. The lesbian approximation. The lesbian approximation are effective interaction area between two spheres. Effective interaction, right? Area between two spheres. suppose we have two spheres, spherical particles. So what area is effective? What area can be thought of is equivalent to the dominating area for the interaction? Look, there are two spheres like this. Two spheres. So here the area is very small. Here the area gets bigger. And at the diameter of particles, the area will be
Makes
the
sense.
highest and then decreases. But at the same time, the area goes farther away, the separation gets larger. Right? So what is the effective area that can be considered as dominating the whole situation? We want to find that area, right, of the disk. We know that the effective area between a sphere and a plane, right? The interaction energy between a sphere and a plane. We have done this.
Yes, sir.
So we know that the interaction, I will write it like this. The interaction
Sphere.
energy between and a plane
And sphere.
surface. That was equal to minus 4 pi square C rho sphere R, where R is the radius of the sphere. If you remember, we had an equation like that. And n minus 2, n minus 3, n minus 4, and
N minus
n minus 5, and d to the power n minus 5. This was the interaction energy between a sphere and
plane.
a plane surface. Now we just derived the interaction energy between two plane surfaces. Right? Between
Sphere.
two plane surfaces. I'll move over the pointer area with
Yes, sir.
surfaces between two plane surfaces. I will write it like that. The interaction energy between two plane surfaces, that was equal to minus 2 pi, right? C rho square. A is the area. Look, the whole area, that was per unit area. And if you want to find the interaction between some pieces of area, then you have to multiply that area with it. And the area was multiplied. N minus 2 area no a bazai pani so I came to them with one bully open.
Yes, sir. I give area no.
Area of one open.
D, sir.
But then I'm going to you wait for Guru Peda. Do us again of sushi.
Yes, sir. Yes, sir.
No, I area to the double.
So you the unit.
No, multiplication the total number. N minus 4, and that is 2. Right? If A effective is the area, right? If we have the separation between two if we have the separation is what? Separation if the separation between a sphere and a plane surface is what? D. So if A effective is the area of the sphere for which this interaction becomes like the interaction between two plane surfaces.
Yes.
There is some area, right? So I will write A effective is the area. Suppose A effective is the area at which
The sphere.
these two interactions are equal,
The sphere behave like a plane.
like a plane, right? So we will say then our condition is W plane is equal to W plane, right? So we will write minus 4 pi square C rho square into R over n minus 2 n minus 3 n minus 4 and d to the power n minus 5, that is equal to minus 2 pi C rho square. I'll call right here E effective and n minus 2, n minus 3, n minus 4 and d n minus 4, equating the two equations. So I will get 2 pi r over n minus 5 is equal to A effective or D. I get from these two equations equating, then I get this simple relationship. Right? Yeah, that's it. A effective is equal to 2 pi r over n minus 5 a d. Right? That will be the effective area between a sphere and a plane. A separation,
D.
and that depends upon what?
R.
That depends upon R. Right, the radius of the sphere.
And also depend on D.
D as well. Greater is D, greater should be the effective area.
Yes.
So this is equation number 3. Right? For van der Waals situation, N is equal to
6.
6. Right? So A effective is equal to 2 pi RD.
Yes, sir.
Right? That is for van der Waals situation. The effective area between a sphere and a plane such that they behave like two planes per unit area. This should be the effective area of that that sphere. Good. That is the effective area of the sphere. 2 pi r,
D.
and it takes into account the d separation as well. This is question number 4 or what? This equation is called the Langevin approximation. the
4.
plane speed approximation. Plane speed approximation.
Equation 4 or equation 3?
Both.
Both.
Yeah. Right? But this is for van der Waals situation.
Yes.
So the separation gets very, very small. Alright? The effective area should be like this. Look, that is plane, and that is a spherical surface, right?
Yes, sir.
No, da om vi var på förska, det är så oema, radius r vad det var. Sayda, au, lit. Das ist so, dass det bara x. Tamam. Och that man z equal to 0 detta. And the separation is
D.
D. Right? Does that make sense? Säg det eller? That's the z, right?
Yes, sir.
See? Huh?
Yes, sir.
Okay. Cartesian value. See, x square is it? Down to बराबर r square minus r minus z whole square, right? And if z is very, very small than r, this z is very, very small than r, then x square equal to, right, 2 r z. X square is equal to, and pi x squared is equal to 2 pi r 2 pi r z, right? Pi x squared is equal to 2 pi r z. So when z is equal to d, right? When z becomes equal to
D.
d, right? If z equal to d, then pi x squared, that area of the disk,
Yes, sir.
that is effective,
Effective.
right? You cut it. That area of the disk, that will be a disk, is equal to 2 pi
RD.
RD, which is the effective area of the interaction that is dominating the interaction energy between a plane surface and a sphere. So that is, we will say, this is the effective area, right, for interaction between
Plane.
a sphere and a plane surface. So that effective area is actually the area of a disk such that this z is equal to
D.
which is the separation between them. وصلت الفرقات. Now we want to derive the force between a sphere and a plate surface, right? Force between a sphere and a plate surface. Right? Force between a sphere and a plate surface. So we know the energy, and we can derive from there the force, because the gradient of energy is force.
Force, yes.
So we know the energy between a interaction energy between a sphere and a plate surface, right? That was a sum separation D once equal to minus 4 pi here rho square C and R, right, and n minus 2, n minus 3, n minus 4, n minus 5, and d to the power n minus 5. That was the energy. Now we know that F will be equal to minus dW by dG, where d is the separation. You changing the separation. You are, when you want to find the force, you have to differentiate the energy
With respect to
right,
separation.
with respect to the separation. So F is equal to minus dW by. So when we differentiate this, we get minus 4 pi square rho square C R for n minus 2, n minus 3, n minus 4, and d to the power n minus 4. Right? N minus 5 converts to n minus 4 by differentiating. So then now the energy per unit area between two plate surfaces. Energy between two plate surfaces per unit area. Between energy, huh? Between two plane surfaces per unit area. That is equal to P. I write P between plane surfaces. So इधर minus 2 pi rho
Square
right rho square into
C.
C divided by n minus 2, n minus 3, n minus 4, right, and
D power.
d to the power n minus 4. That is equation 3. So look, this force contains this energy, right? So 3 and 2. So we get what? F, the force, right? The force between a sphere and a plate surface. That is equal to, right, 2 pi R and W GL in terms of the plane surfaces, the energy of plane surfaces. I am getting the force between a sphere and plane surface in terms of the interaction energy per unit area between two plane surfaces. Right? So this relationship distribution is four. These are different geometries. Look, this is sphere, and this is between. So a sphere relating to plane, converting, like making the energy between a sphere and a plane surface in terms of two plane surfaces, equating different geometries with each other, how the interaction energy would differ if this were in the form of a plane surface. Getting the energy between a plane surface and a sphere if they were both two plane surfaces. Right? So this is a relation. You get the force between. The Now we want to bring geometries into this was between a sphere and a plane surface. Now two plane surfaces, right? In terms of, right? Now, two spheres. Two spherical particles. Two spherical particles. Right? In terms of two plane surfaces. Two spherical particles getting the energy are between two spherical particles. In terms of the energy between two plane surfaces per unit area. Right? And this situation, when we get this, this is called the diagonal approximation. The diagonal Doctor complex full approximation system. Mathematics gets very complex. Therefore, people have no other option but to use approximations to make things simple. Approximations are used to make complex things simpler. Right? So we will this diagonal approximation gives you the force between two spherical particles of radius R1 and R2, the force between them, right? Take a separation of D, right, equal to 2 pi R1 plus R2 divided by R1, R2, no, R1, R2, and R1 plus R2, and W D, right? And one is the radius of the first is R1, and the radius of the second is R2. Right? F of D is the force between two spheres, and W of D is the interaction energy, right, per unit area of a plane, of two planes are there, of two plane or floor, plane or floor. Right? So it will be like two spheres, right? Say that. And R1 and R2 and we count from here z equal to 0. Not to worry about. Okay, so what we do is we consider small kind of cut here, right, to find the effective area. Right. So we consider a small ring kind, right, here. And a small ring on this side. Right. So these are separated, these two, they are separated by, this is Z1 suppose, and this is Z2. The two rings are separated by a distance what?
Z1 plus B plus
Separation between the rings. Separation between the rings. Right? That will be G plus Z1 plus
Z2.
Z2, alright? And the area of the ring, that will be right? Then it will be 2 pi x and dx. 2 pi x is circumference and dx is a
Small
little small distance
Increment.
along the radius,
Increment.
right? Along.
Radius.
So from that previous equation, right, we can find the force between these little rings, right? That in terms of the interaction energy, right? So
Sir, the Z1 becomes a distance thing.
Z1 is the distance, this is Z is equal to 0 here. For this. So it is like 0.
Come there, Puri, sir.
Next to this
Radius Puri.
ring for it.
The ring radius Puri kana.
No, the center of the ring. That's 2. Right? When you cut it, this is D.
Yes, sir.
When you cut it here, this is Z1, Z1 or Z2. This center of the ring. That's it. Direct cut. Look. Eu cut și da. That's sphere, but that's equal. So this is Z1, this is double na that taraf cut share. They give a pulp that Z1, Z2 will do
Yes, sir.
this way work.
Yes, sir, please. Yes.
Okay. So that force is equal to dF G, right? A separation, the force, right? In terms of F 2 pi x dx, 2 pi x dx, and f of z. That is, look, that is the area of the ring, and that is the force per unit area. The little increment of force per second, solar area, that's the
Force per unit.
per unit area multiplied by A is equal to the resultant force. A small increment of the force. You know what I'm saying?
Yes, sir.
It will be like, look, that is x. So, density x.
Yes.
So you can our bang ratio. dx, the hazard of your dx. Understand your delta. Say that?
Yes.
Then this, and that is the. So this is 2 little rings.
Yes.
The interaction force, the force between 2 little rings of size dx.
Dx.
So if I want to find the force between these whole discs, I will have to integrate this around the whole area of the disk. Masa daras bir hatam diyoruz. The two rings diyoruz.
Yes.
Two rings. This, suppose one is bigger ring and one is smaller ring,
Yes.
right? 2 pi x is the circumference and x is the radius of the ring. So now if I want to find the interaction area, the interaction between two whole disks, so I will have to integrate this ring over the area of the disk. This disk को picture है ना?
Yes, sir.
That disk şurası. This is disk. So that is, this small is the area, the ring. And this is the force between two rings. If I have to find the total, then I have to integrate over this whole area.
Yes.
So I have to integrate the ring over the whole area. So the force between two spheres, right? That will be equal to the force between the two spheres. Between the two spheres, right? F of d equal to, integrating from z is equal to d to infinity. Right? To infinity. 2r na biorąc to porque se ništa contribution, no infinity to was on
Yes, sir.
So that will be 2 pi x and 2 f of z, right? And dx. Right? Give me the f of z, right? You want to show this? You just have a.
Yes.
So from the chord theorem, right? From the chord, which is what you call the chord theorem. From the chord theorem, x square is equal to 2r into z. A chord theorem.
मुझे approximation नको. Z less than 1. X.
That's the r or the r minus 0.
That's it.
0, that's the correct.
The part 2.
Right? Remember the situation to x, y. Nine. Then the soil was x. Without x there. जब ये सीक्यू में जरूंगा ये हो किताब राइट और आगे के मकाले चले ओके فبي فروت انترفيروميتر आगे के मकाले ما يكلاس ما هو كذا شيء سنجر هذا زو ودينا كويس when I was in the PS. Okay, so x squared is equal to 2rz, and it can be written as, right, 2r1 z1 for this one square. It can be equal to 2r2 z2 for the other one. Right? And the separation is, so from here I can get z1 equal to x squared by 2r1. And from here, z2 equal to x squared by 2r2. So I put these in the separation, right? the separation is equal to d plus z1 plus z2, separation between the two disks. And I can write this as d plus x over x squared divided by 2. Or where was she? 1 over r1 plus 1 over z1 z1 double लिखा, z1 double लिखा, z2 double लिखा, x by 2 दिव्या काम होगा तो सही. So if we want, this is I will say z equals
Separation.
the separation. I think is z because it is along the z axis.
Yes.
So I call it z. Now dz will be equal to, that is constant separation, and we are finding the effective area, and we are integrating over the volume of the sphere. So that will be equal to 2x, right? And 2x will go.
Cancel.
And it will be x, right? And 1 over r1 plus 1 over dz equal to this. And what? That will be dx. Differentiating that? Differential. So, now I can find dx from here, right? Dx equal to r1 r2 divided by r1 plus r2 and dz or
X.
x. Right? So let me put this in equation 2. Apply this equation 3. So I put 3 in the diode है तो मैं देता हूँ 2 है लेकिन नहीं रहेगा देता 2 है और 1 से लेकर आराम बने जाओ जो बोलो देता 2 है. So f of d will be equal to, say that, f of d, you integrate from z equal to d to infinity and 2 pi, और x पता है कि value बोलो बोलता x, क्या करें? dx per se, right? Huh? dx per se to x per se मैंने फिर बताया. और dx per se किसको r1 r2 by x and r1 plus r2 and
DZ.
so x goes
Cancel.
right, and we get what? 2 pi r1 r2 divided by r1 plus r2 f of z. But they will still be equal to f of z.
Yes, sir.
Per unit area, interaction energy, force, right? Force per unit area. So that is f of z into dz. Or dx set to the So that means let us mark this a force. Now force is equal to dW by dz. Huh? This is dW by dz equal to 2 pi r1 r2 divided by r1 plus r2 and dW by dz into dz which can this is equal to the reciprocal effect, and that will be d of W from d to infinity. Say that, and this will be equal to 2 pi r1 r2 divided by r1 plus r2. That is force, right? Force at separation
D.
D. And this is the total direction energy at D. And this is the force per unit area. So this is the energy per unit area. So that is the interaction energy per unit area. So this is the force in terms between two spheres. In terms of the interaction energy between two plane surfaces, and this is per unit area. Planes are on the per unit area. Why is it a plane bearing? And this equation is called the Daryagan approximation. This equation number 5 or 6? 5. That is called the Daryagan approximation. The equation which gives the energy, right, between two spheres, or the equation which gives force, right? The equation which gives force, right? Say the column. The equation. Dimension side or something?
Oh, but dimension is correct, right?
Energy का column, right? Looks right column. F is equal to
dW by dt. ZS.
सही है
Joule per meter.
Dodajcie się dodaję na co dimension rashi dW number capital force into this distance for rashi. This is answer that.
Land is a प्रकार D non-linear is a प्रकार.
Look, that's it.
Interaction energy between two planes.
Interaction energy per unit area.
Yes.
दूसरी लाइन इधर लगी एरिया है W की एनर्जी था और लाइन डिनोमिनेटर के साथ एरिया है उधर से चिकन R पाती शी यो R ऐसे खत्म शी उनके डायमेंशन सही है सामने पुश भी करूँ लिवा
Yes, sir.
देखिए हेड आंसर है जाता
Area
लाइन डिनोमिनेटर की नो R एरिया सरमा को दे R सरमा यो R खत्म शी बराबर यो R पाती शी नो अगर एरिया से लाइन यो R खत्म शी you are not the party dimension. Special cases of how you go.
बस वही सर
No, تفضل كتاب. ها؟ كتاب بلاستيك.
خلي
كنا يقرأون. اللي بقى.
ختمية بس هي
ها؟
كان في ختمية كده سيء
بس يو دول تكي ده يا أخي دوس رتونا دي.
يس
زي question 6 تسوي. زي which gives the force between two spherical surfaces of radius r1 and r2. Right? Suppose spatial cases. Spatial, C-I, spatial cases. Right? One. If R2 is very greater than R1 كوارث 2 كوارث على الطوال
ديدر
كم
ديتر طبعا R1 ديتر طبعا look that's it that's it over this suppose this is kind of you're going to football they will go sugar than that what is space the force of the second one f of t will be equal to look they will work R2 very greater than
R1
R1 they don't get
R1 बहुत अच्छी yes
صحيح so R2 this R2 بقدر شيء صرف R1 بس R2 is very greater than R2 is very greater than that ممكن equate to R2 بعد
yes sir
then R2 صرف R2 خطر شيء
yes
R1 so what the dominating factor is the radius of the small what such the measure piece the small particle size so they are measure so that will be 2 pi R1 then तो बस हो जाएगा 2 pi R1 W and this is interaction energy between energy two flat surfaces per unit. Okay. Sorry?
yes
When the two are suppose equal, what are you saying, Pascal? Case number 2. When if R1 is equal to R2 is equal to R, when the two are
equal
the same radius or the same size, that's it. Right now? Oh, that was it. R. Then the force will be equal to at separation D will be equal to 2 pi R squared divided by 2R and W D, right? So that will be pi our R D. Say that? Huh?
yes sir
Oh, that's great. 1 over 2 or 2 pi R. That's the equation.
yes sir
When the radii are equal, the force does it say that?
direction is very
Coordinate area between two plane,
plane. No dá se cheio?
between two sphere.
Então assim FSS equal to 2. Then dá se cheio F spheres and plane. Christmas class na bom, fazer. Mas fazer. Eu gosto de pequena assim. So look, I can't say wait. No. When the two are equal, the force is like half of the force between two plane surfaces. Right? Down there,
Yes, sir. Yes.
down sir, you small or you or the sphere द्वारा you small or you
Larger.
large. सही ना? So down here the she और down sir आगे बराबर हो दा कितना शुरू करी down sir बराबर हो a sphere and a flat surface बराबर हो दा same हम कितना शुरू करेगा your molecule or your surface का भी इतना relation बराबर हो that's the thing. That's the you radius did roughly.
Yes, sir.
You did model TV. That is equivalent to the your plane surface or your spherical surface. But we just see
Yes, sir.
that's it, learning. This was the 1 was 2, right? And that is like that's it.
Yes, sir.
Data will
Sphere.
sphere or sphere for the condition that is now okay.
Yes.
Size will be option. Take it now.
Yes.
No curves are